Okay, so this is 2.3 set operations. This is our second video. So we have some new objectives. Our objective is to find the intersection of two sets. So we're going to define that. We're going to find the union of two sets. We're going to define union. We're going to perform operations with sets. We're going to find the intersection and the union of some different sets. We're going to determine sets involving set operations from a Venn diagram. So we're going to draw a picture involving the intersection and union of two sets and determine which elements are a part of that set. We're going to understand the meaning of AND, which is intersection, and OR, which is going to be union here. And then we're going to use the formula for finding the cardinal number of the union of two sets. And we're going to use a Venn diagram to help us understand that. Okay, so on to the definitions. So the intersection of sets, we're going to have our definition, the intersection of sets A and B, written A intersect B is the set of elements common to both set A and set B. So because it's a common element in both, as part of our Venn diagram, the idea is the intersection is this second region in between the two. Alright, so that's the overlap right there. And so generally, this is going to be a smaller set because it's got to be in both. It's got to have characteristics of both. This definition can be expressed in the set builder notation, but I think this notation is very nice right here. Okay, so let's do some examples of finding the intersections of two sets. Now, if we're going to find the intersection here, what we need to do is we need to find elements that are in both. So 7 only shows up here, but I do have 8 in this set and in this set. So I'm going to put my brace in and put the 8 in. Alright, and then 8 I have in this set, but not in this one. 10 I have in both sets, so that's going to be in the intersection, of course. And then I have 11 over here, but not over here. Alright, and you'll see that 6 and 12 do not show up in this other set either. So the intersection of my two sets is simply 8 and 10. And you'll notice that it is smaller than the other two sets. Alright, either one of them's cardinal number. Alright, so what about this one? Okay, so 1 is here, but not over here. 3 is here, but not over here. 5 is here, but not over here. 7 is here, but not over here. 9 is here, but not over here. Oh, well, if you look, these are all odd numbers, right? And these are all even numbers, and so there's no overlap. And so this is going to be the empty set. There are no elements in either one, and that certainly is smaller. All right. Now, here's just a nice property. Any set A intersected with the empty set will be the empty set. Okay? There are no elements in the empty set, so it can share none of these elements with any other set. So this is always going to be the case. So this is the answer to C right here, and it's kind of a property, and that makes us happy. Okay? What about the union of sets? So the definition of the union of sets is the union of sets A and B, written A union B. See how it looks like a U? Is the set of elements that are members of set A or of set B. Okay? And so this definition can be expressed in set builder notation. It's also pretty nice to see with the Venn diagram, right? So here, of course, is set A. Here, of course, is set B. And, of course, all of these elements, let's change colors, all of the elements in A or all of the elements of B are part of it. And so you're like, oh, so it's all of this area. All of these elements are part of this new bigger set. And so unions are almost always bigger sets, okay, instead of smaller sets. And that's because of the OR as opposed to when we had the intersection of our sets that was the and. And that was one of our learning objectives, right? So we want to make sure that we understand that. Okay? So there's our union of sets. And now let's do some examples, right? So here we go. Find each of the following unions. Well, remember, it's every element here and every element here. But do not repeat elements. I think this is a big mistake that students make, is they repeat elements. I'm sorry that got squished. That makes me sad. Okay? So I'm going to put my braces in for the start of my set. I'm going to put, well, 6 is the smallest one, but we don't have to go in rank order. Alright? So 7, 8. The 8 is already over here, so I'm not going to write it again. 9, 10. The 10 is already over here, so I'm not going to write it again. 11, 12, and then the 6, right? Now, if I really wanted to, I could erase just a little bit here, right? And we could go back and we could put them in order, and that would make me happy. Okay? But remember, they don't have to be in order. The elements don't have to be in order, but there they are. Okay? Now, if we look at this union, remember, these are our odd set. Again, this is our odd set. This is our even set again. Okay? And so now we're going to union them, so we're going to put them both together. And so this one is just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And so that's our new set right there. That also makes us very happy. Now we have a new property. Now we have the union with the empty set right here. Okay? And now when you union one of the empty set, it's kind of like adding 0. Doesn't change anything. Okay? And so a set A unioned with the empty set is set A. It's not going to change in any value. So here the answer is 1, 3, 5, 7, and 9. Alright? And that makes us real happy because it's like our 0 property of addition. So that's great. Okay? So we're just going to summarize that now. We've already talked about it, but any set A intersected with the empty set is the empty set, and of course the A union with the empty set is just A. So this is kind of like multiplication. Okay? This is the analogy for it, because remember, A times 0 is always 0. This is kind of like our addition, okay, here, because A plus 0 is just A. So you see a very similar idea in the addition and multiplication with the intersection and the union. Alright? Just as a little aside, connecting things to what we already know. Okay, so now performing some examples on the sets. So what are we going to do here? So U is 1 through 10. Okay, that's our universal set. So now we can talk about the complement here, right? A is going to be our 1, 3, 7, 9. B is going to be 3, 7, 8, and 10. And then we're going to remember to always perform any operations inside parentheses first. Okay, so this is our orders of operation. And of course, parentheses first, our grouping symbol first, is super important. Okay? So here, we want to union A and B and then take its complement. Alright? So let's first find A union B, and then we'll take its complement. So A union B is going to be 1, 3, the 3 shows up in both, but I only need to write it once. 7, the 7 shows up in both, so I only need to write it once. 8, so I go in order. 9, and then here's 10, okay? So that's A union B. So I put those two sets together. Now I need to take the complement. So A union B's complement is everything not in this set, but still in the universal set. So as I look, 1 is in the universal set, 2 is in the universal set, but not in A union B. 3 is there, 4, 5, and 6 are not, so we want to write 4, 5, and 6. Okay, and then 7, 8, 9, and 10. 7, 8, 9, and 10 are all in A union B. And so those guys are not going to be in the complement, and so there's the complement. And that makes us happy. All right? And I find it very helpful, and hopefully you will too. I find it helpful to cross things, elements out as I go. All right? Now, this is a mess, so what I'm going to do now is let's go ahead and erase all of this loveliness right here. And then in a different color, we'll do this one, right? Okay, so now you want the complement of A intersected with the complement of B. Well, really what I need to find is A complement first, okay? So everything that's not in A, that's in the universal set. So as I look, 1 is in A, so I don't want to use that. 2 is in the universal set, but not in A. Okay, 3 is in A. 4, 5, and 6 are not in A. 4, 5, and 6 are not in A, but they are in the universal set. 7 and 9 are not in A, so 8 and 10, right? 8 and 10. Great. Now we need B complement, so that then I can do the intersection. So B complement, well, 1 and 2 are in U, but not in B. 1 and 2 are in U, but not in B. Let's see, between 3 and 7, right? So 4, 5, and 6, again. 4, 5, and 6, again. Then you have 8, 7, and 8, and then 9 is missing, right? So we need 9 from over here. Great. So there's the 9. So we want to do the complements first, and then do the intersection of the set. So the order of operations here is going to be the complements first, and then the intersection. So now we're ready to put this all together. A complement intersect B complement. And now, of course, we want to put just those things that are the same together. Okay? So 2 is in both, right? That's the same in both. So 2 is going to work. 4, 5, 6, and that's it, right? Everything else is different. So that would be the intersection. And that makes us happy. Not blue, but happy. Ta-da! Okay, so those are our operations with sets, and even some sort of advanced operations. Okay, so now we're going to be determining sets from a Venn diagram. This is very helpful to be able to look at the picture. So A includes these 4 irrational imaginary numbers, okay? B includes these 5 numbers right here, and then of course U contains this additional guy, which we'll put in red for obvious reasons, out here that's part of the universal set but not A and B, okay? And so now what we want to be able to do is to look at the Venn diagram and determine what A union B is, okay? And so we're going to set up our braces here, and A union B is going to be all 7 of these numbers, and the only number we're going to exclude is the 666 because it's outside of A and B, right? So we're going to have pi, we're going to have E, we're going to have the square root of 2, and we're going to have the square root of negative 1, our imaginary number. And then we're going to have in B, we're going to have e to the pi I, which is called Euler's number. You're going to have 10 to the 100 power, which is not quite a googolplex, but a pretty big number. And then 2 to the elf. Right, so we got our special elf not here, which is our natural numbers, right? And then we want to close up our set. So this is our 7 values for A union B. Now, A union B complement is A union B and then everything outside of it, but still in the universal set. And the only thing that is there is, like we said before, the 666. So we'll put that guy out there because that's a special number too. These are all special numbers, so that's a special number, I guess. Okay, so let's go ahead and look at C and D, right? And do these 2 examples right here. And so you have A complement is everything outside of A. So A complement is going to be all of these, right? So there's my A complement, everything outside of A, intersected with just B, okay? So just B is these guys right here, okay? And so you're just looking at the set of elements, Euler's constant, e to the pi I, 10 to the 100 power, and 2 to the elf not. So that's the answer to that set. And then, of course, A union B complement is slightly different because remember the union makes everything bigger, right? So let's erase our notation here, okay, and take a look at this. So A is all of this, okay, so we're going to have all of that, and then union with B complement, everything that's outside of B, okay, so you want to have everything that's outside of B. Well, what's outside of B is over here and these guys right here, okay, and then of course what's inside A are these 2 guys right here, okay, so you're going to have these 5 elements all together. So you're going to have pi and E and the square root of 2 and the square root of negative 1, and then you're going to have the 666. The only thing that we're going to exclude are these going to be these 3 guys right here because they're outside of A. Okay, they're outside of A, and they're inside of B, so they're not part of B complement. So those 3 guys right there are excluded. Okay, so again, circle, make notations on the graph. I think these are all things that are really helpful with the Venn diagram to help us see what's inside, what's outside, and those kinds of things. So don't be afraid to draw the picture and make the circles. Okay? Alright, now sets and precise use of everyday language. Remember, set operations and Venn diagram provide precise ways of organizing, classifying, and describing the vast array of sets and subsets we encounter every day. So this will be part of your project. And as we've said before, the OR refers to the union of the sets, and the AND refers to the intersection of the sets. So when you see these 2 words, you can translate them into these 2 mathematical symbols when we're talking about sets. Okay? Finally, the cardinal number of the union of 2 finite sets. Alright? Now, why is there a special formula for this, right? You're going to find the cardinal number of A union B. Okay? Well, a lot of times A is going to look like this, right? We're going to use a Venn diagram. And B maybe has some elements in A. So we're going to go like this, and this is our B. And so what happens is this is going to be equal to the cardinal number of A, all of the number of elements in A. Okay, so here's all of my elements in A. Alright, and we call that N. Okay, and then we're going to look at, and we're going to add all of the elements in B. Well, all the elements in B are over here, right? These are all of the elements in B. We'll say that's like N, okay? And you look and you go, whoa, 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 whoa. There's some stuff in here that we've counted twice. I've counted some of these guys twice in this intersection, in the overlap. In the intersection of those two sets is some overlap that we need to subtract off. So we need to subtract off the overlap from the intersection, and just one of them. So basically what happens here is if I subtract out this, if I subtract this out, put the B back. What I'm going to do is I'm just going to subtract out just maybe the A parts that I've counted twice, and that will leave me just the B parts, and now there is no overlap, and that makes me happy. So because of overlap, I'm going to count elements twice, and so I need to subtract off once. So I'm going to subtract once. Okay, and that makes me happy. So that's the idea here. Now if there's no overlap, then this is 0, and you don't have to subtract anything. Okay? If B is completely inside A, if you had something crazy like here's A, and then here's B, right? Then what happens is you end up subtracting all of B out. You don't add anything to it. Okay? And that's kind of weird. It makes a little steam come up. Alright, so there we go. So now let's work an example. Let's actually, instead of just looking at this theoretically, let's work an example. So here's our example. Example 8, cardinal number of the union of two finite sets. Now this is going to be very much like your survey, right? So again, we did an example like this in class, but let's take another look. Some of the results of the campus blood drive survey indicate that 490 students were willing to donate blood. 340 students were willing to help serve a free breakfast to the blood donors, and 120 students were willing to do both. How many students were willing to donate blood or serve breakfast? Well, let's take a look, right? So, what do we know? We know that there were 490 blood donors. We know that there were breakfast servers. And we had 120 that were willing to do both. That means that these particular individuals are in this category and this category. This is our overlap right here. So maybe it's helpful to actually draw a Venn diagram. What if I actually drew a diagram of blood donors, and I drew a diagram of the breakfast servers, okay, and in the overlap are the 120, okay? So over here are all of the people who are willing to serve breakfast, including the 120. So that's going to be your 340 that were willing to serve breakfast minus your 120 that were willing to do both. And so you're going to end up with 220 people that were willing to just serve breakfast, okay, including the 120 people that were willing to serve breakfast and donate blood. Alright, so that ends up with your 340 for the breakfast. And that's where that number comes from. Well, I can do the same thing with the blood donors, right? I've got 490 blood donors. 120 of them were also willing to serve breakfast. And so you end up with 370 that are blood donors, okay, only, and 120 that are blood donors and serving breakfast. Alright? So the actual question was, how many are willing to donate blood or serve breakfast? Well, that's each of these three added together. Okay? Because I've already taken out the overlap, right? These 370 are only in here. 370 are only in here. The 120 are only in here. And the 220 are only in here. So I add up those. 7, 8, 9, 10, 11. Carry the 1. 4, 5, 6, 7. 710. And so that number makes us happy. And you go, well, what about our formula? Well, let's take a look. What if you had taken the 490? Alright, what if we had taken the 490? That's the cardinal number of set A. And added the 340 together. So there's your 0. 9, 13. Carry the 1. 8, 830. And then subtract the overlap, right? We just want to subtract the overlap. So subtract 120. And you get 710. Oh! It's as if math works forever and always. So you can draw a picture like we did here, okay? Just being very careful about where each thing goes. Or you can just use the formula of adding up sets A and B and subtracting off the intersection that's in both, and you'll get the same number either way. Alright, that concludes the video. Go on to 2.4.